All right, so in this video, we're going to take a look at just some basic math review, just for the first couple of weeks, just to make sure that we are coming in with the correct or the right foundations. As you will realize in chemistry, there is a significant amount of math involved, specifically when we get next week into next week and the following weeks. This whole idea of dimensional analysis is going to be very, very, very important because that is a technique that you can use, and we recommend that you use to solve lots of your chemical calculations that we're going to see down the road. And we'll talk more about that next week. In the meantime, though, for this week, we're just going to review some of the basic mathematical operations that we see here. And we'll just do a couple examples here and there just to make sure that we get back up to speed. So the first thing, working with numbers. Okay, and specifically now, when you do your calculations, you want to make sure that you always double check with your calculator. So you want to make sure that you know how your calculator works. So become familiar with your calculator operations and buttons. And if you ever have trouble identifying or figuring out how to do, exponent or scientific notation, please double check with me, or you can Google it if you'd like. But you want to make sure that you know how your specific calculator works, so you're not fumbling around when it comes to an exam or a quiz. So let's take a look here at just a couple quick examples. So let's say I had the following. So I had negative 27 divided by 3. And then let's say I also had minus 4 times minus 5. Okay, so for the first one, can you evaluate this? Make sure that you use your minus sign in your calculator, and you can type that in directly as it is. 27 divided by 3 is 9. And when you divide numbers with different signs, so we have a negative sign here in front of 27. The 3, even though you don't see a sign in front of it, positive is understood. So you have two different signs. We end up with a negative value. Similarly, or by the same token with the second one, we have negative 4 times negative 5. And again, you would want to enter this exactly as you see it. So you have your negative 4, you put that in first times, and then you want to make sure you have your negative sign times 5. So 5 times 4 is 20. Now we have our signs here that are the same. When you have the same signs, you're multiplying or dividing, you end up with a positive value. So you can put the positive 20 there, but you don't need to put it in. If you just have 20, the plus sign is understood, or positive sign is understood. So we have 20 as your final answer. So you want to pay attention to signs, especially when you plug them into your calculator, to make sure that you have the right, not just the number, but the sign as well. Now, the other thing that you want to remind yourself of, or to go back and dust off some of the rust, are your place numbers. Okay, so if I have a number such as 1, 2, 3, 5.790. Okay, so when we have numbers like these, you want to make sure that we're able to identify the different places. Okay, so right in front of the decimal point, to the left side of the decimal point, actually, this place here is the ones place. So the 5 is in the ones. The 3 is in the tenths place, or the tens, not tenths, tens place. The 2 is in the hundreds place. And the 1 is in the thousands place. Okay, so this is 1,200. 3 tens is 35 point. And now the 7 here after the decimal point, that is in the tenths place. The 9 is in the hundredths place, hundredth. And then the 0 is in the thousandths place. Okay, so you want to remind yourself of the place numbers when it comes to working with decimal numbers, for example. All right, so the next one here, just a quick review of fractions and simplifying fractions. So we have 18 over 81, and we need to simplify this. So we want to get the smallest whole numbers, reduce this to the smallest whole numbers. So here we want to find the number that can go into each of these numbers that we have. So if you take a look at the lowest common factor of each of these, that would be 9. Okay, so if I divide this by 9, and divide the denominator by 9 as well, 18 divided by 9 is 2, 81 divided by 9 is 9, and that's the lowest, or the simplest fraction that we can get from 18 over 81. We want to get the lowest common, well, I'm sorry, the highest common factor of 18 and 81. So in the next one, we'll take a look at sort of a combination of fractions and signs. So we have 5 over 3 divided by -9. Okay, so when you have something like this, a couple of ways you can approach it. This means the same as 5 over 3 times 1 over -9, right? So you can express this when dividing by a number, you're putting it over that number. It's the same as multiplying by 1 over that value. And expressing it this way now, we can just evaluate the numerator and the denominator. So 5 times 1 is 5. 9 times 3 is 27. Now we have to consider the sign. We have a negative sign, positive on the top. So overall, then, this would be -5 over 27. All right, and now we'll take a look at just a brief review of exponents. So the first one here says to write 2 times 2 times 2 times 2 using exponents. So when it comes to this, right, so we're multiplying 2 times itself, and then it's multiplying by itself 1, 2, 3, 4 times. Okay, so 2 to the 4 is 2 times 2 times 2 times 2. So 2 to the 4, 2 to the 8, 2 to the 16. Similarly, 2 squared would be 2 times 2, which is 4. 2 cubed would be 2 times 2 times 2. 2 to the 4 2s are 8, and so on and so forth. Let's take a look now at some other examples of exponents. So here we have evaluate 10 squared, all right? So just like with the previous one, 10 squared is the same as 10 times 10. 10 times 10 is 100. What about 10 to the -2? So what is that equal to? So 10 to the -2, when you see that negative exponent, that means 1 over 10 to the 2, which is the same as 1 over 10 times 10, which is the same as 1 over 100, or 1/100th. You express it as a decimal, 0.01, right? So you'll see all different ways to represent numbers, exponents, and when we get into scientific notation, that's going to be really, really important for dealing with really big and really small numbers. All right, let's take a look at the next one. X to the 4 times x to the 5. So often in chemistry, you'll see this little dot here. That dot means multiplied by. Okay, it's not a decimal point, as in the strict sense of the word. It's multiplication. So when you have exponents that you're multiplying, what you do is you simply add those exponents together. So x to the 4 times x to the 5 would be x to the 4 plus 5, which would be x to the 9 as your final answer for that one. Let's do this one. So we have now x to the -4 times x to the 7. Okay, same thing. We have now x, and since we're multiplying, we're going to add those exponents together. So we have -4 now plus 7. -4 plus 7 would be 3. That's your final answer. Let's take a look at, we'll do dividing exponents. So we have now y to the -6 divided by y to the -5. So when you divide exponents, you simply subtract them. So this would be the same as y -6 minus, now you can think of the minus sign as that division sign, and then you're subtracting now -5. Okay, and that's probably the most critical part of this right here, because you actually have the division, which means subtracting, and you have your -5. So this one will be the same as y to the -6. A negative times a negative is a +5. So this is the same as y to the -1, which is also the same as 1 over y, right? Anything to the -1 is 1 over that number. So 1 over y, or y to the -1 would be that. And then our last one here, we have 3v squared times -7v to the 6. Okay, let's rewrite that. So 3v squared times -7v6. Okay, so similarly, when we multiply, okay, so we have the 7 times a 3. That's going to give me 21. A positive value here, negative value. So this is going to be a negative value. And now my v's become v to the 2 multiplied by v to the 6. So 2 plus 6. This gives me -21 v8 would be your final answer for that one. All right, and let's take a look at a couple more, or maybe one more in the exponents, and then we'll take a look at some manipulating equations. So let's say we had something like this. We have 3b 4 and cubed, all that cubed divided by 6b squared, and all that squared. And we need to simplify this. Okay, so let's take a look at each of the parts here, the numerator first. So 3b to the 4 cubed is the same as 3b4 times 3b4 times 3b4. Okay, so that gives 3 times 3 is 9, times 3 is 27. And then when you have, now you can see this when we expand this out, when you have an exponent raised to a certain power, as opposed to just multiplying it where you add them together. So it's not 4 plus 3, which is 7. It's now 4 times 3, which actually gives you 12 here as your new exponent. And then that's divided by everything in the denominator now, 6b squared. So that's the same as 6b squared. Whoops. And that's itself a squared times 6b. So 6 times 6 is 36. And then you have your b squared times b squared would be b to the 4. Okay, we can simplify this even further. Highest common factor of 27 and 36 is 9. So 27 divided by 9 is 3. 36 divided by 9 is 4. And then our b to the 12 now divided by b to the 4 is the same as b to the 12 minus 4. So that gives 3 over 4 b to the 8 as your final simplified version of this. Okay, so there's some shortcuts you can take. So knowing, for example, when you have an exponent, you raise it to a certain power, you multiply these together. So 4 times 3 is 12. Give me my numerator. 2 times 2 here gives me 4, denominator. And then the same thing with the actual coefficient. 3 to the 3 is 3 times 3 times 3, 27. And then 6 squared would be 6 times 6. All right, let's take a look now at some algebraic manipulations. So in other words, solving for one unknown in a problem. Oops. Sorry, I lost my screen. Okay, there we go. So for example, if we have something like 3x plus 10 is equal to 16. We need to solve this for x. Okay, that means we need to find what x is, what's the value for x. I'm going to isolate all the terms with x on one side. So we have our 3x now is equal to 16. We'll need to take the plus 10, move it to the other side. We move it from one side to the next. We change the sign to a negative sign. So 3x is equal to 16 minus 10, which is 6. And then in order now to isolate just the x on the left side, we divide the left side by 3. So that cancels whatever we do to one side of an equation, we do to the other side. So we need to divide the other side by 3 as well. So x is equal to 6 over 3, which is 2. If we take a look at another example, let's say I have negative 4 is equal to 8m plus 18n. And I need to solve for n. Okay, again here, you want to isolate the term with n on one side. So there it is. So 18n is equal to now negative 4. That's still on the left. I'm going to take my 8m and move it over. Change the sign now to negative 8m. To isolate just n on the right side, I need to divide that side by 18. I need to divide the left side by 18 as well. So this then becomes n is equal to negative 4 minus 8m divided by 18. Let's take a look at another example. If I have 2 into 3y plus 3 minus 8y, and we need to simplify this. Okay, so when we simplify it, we want to expand out and then cancel things out. So when you have your number in front of the number in parentheses or whatever in parentheses, you multiply it by each of the terms individually. So 2 times 3y gives 6y. 2 times 3 is 6, and that's a positive sign. Then we have our minus 8y. Okay, so now we look at our terms. You can bring the like terms together. So 6y minus 8y plus 6. 6y minus 8y is minus 2y. And then plus 6. That would be your simplified version, or you can switch them around. It can be 6 minus 2y. That means the same thing. If we take a look now at another one, so let's say that we had something like d is equal to 4 over 7 into f minus g, and we need to solve this for g. So isolate g on one side. Now, as I'm going through these examples and reminders, now keep in mind that there's usually more than one way to solve a problem, especially a math problem. You may do it a slightly different way. As long as you end up with the correct answer or the right answer, that's really all that matters. Your technique, your strategy may be slightly different. All right, so let's say now, let's take a look at what we have. So we want to isolate this for g, right? That's this term here. So let's expand this out and see if we can simplify it even further. So d is equal to 4. If I multiply this by each of these terms, so 4f minus 4g, all of that now divided by 7. Okay, and now I can cross multiply. So d is the same as d over 1. I end up with 7d is equal to 4f minus 4g. Okay, I'm going to isolate just the g term on one side, so minus 4g, or I can move the 4g on the other side, just so that we end up with a positive sign. So move this over here, and I'm going to move this over on that side. So I end up now with 4g. I moved it from left to right, so the sign changes to positive, is equal to 4f. I move my 7d to the other side, sign becomes negative. And now I need to divide this left side by 4 to get rid of that to end up with g. I need to divide the right side by 4 as well. So g then is equal to 4f minus 7d over 4. this is the same as 4f over 4 minus 7d over 4, which is the same as f minus 7d over 4. And that is equal to g. Okay, that's one way to solve it. You could have done it a slightly different way. Doesn't matter, as long as you end up with the same answer. All right, so we'll take a look now at the last thing here with graphing and specifically how we interpret the slopes of graphs. So graphs are a really good way to show the relationships between two variables, typically plotted on an x and a y axis, x being horizontal, y being the vertical axis. So when it comes to looking at the relationships, our graphs can have a variety of shapes, and most simply, the simplest ones we'll see, for example, let's say we have a graph sloping this way, let's say in red. Okay, that slopes, it rises from left to right. We say that has a positive slope, and we'll talk about slopes here in a second. If your graph slopes downwards this way in orange, this has a negative slope. So you want to, when you graph your data, when you look at graphs, for example, just identifying what the slope actually is important to start with. So let's say we have a set of axes and we have our line plotted that looks like this, right? So let's say we have two data points right here in red. We have another data point right there in red as well. So we can represent these points. When we plot these points, we usually have the x value written first. So the x value for this point here is 3. And then the x value, the y value for that same point is 6. And then for the second point, or this other point, the x value there is 1, and the y value is 3. Okay, so using these data points from our graph, we can determine the slope. And the slope we can think of as the rise over the run. Okay, and the rise is simply the difference in the y-axis between, you can pick 2 points, and we have our 2 points selected, divided by the difference in the x-axis between those same 2 points. Okay, so the other way, or the way that this is represented mathematically, we say the rise would be y2 minus y1, and the run would be x2 minus x1. So what are these values? Well, if I select this here as my initial point, this one here would be my x1. This 3 here would be my y1. Okay, that's the y value, and that's 3. The x value there is 1. And then my second point here, the 3, 6, the 3 here would be my x2. And then the 6 there would be my y2. So all I need to do is to stick those numbers into my equation. My y2 there is 6. My y1 was 3. My x2 was, what was that, 3. My x1 was, is that right? Yes. So 6 minus 3 is 3. 3 minus 1 is 2. So my slope there is 1.5, right? And that is a positive value, right? And that makes sense because the graph actually slopes upwards, right? It's increasing from left to right as we go across this set of axes. So we can determine the general nature of graphs, just how they look: positive slope, negative slope if it slopes in the other direction. We can identify the slope by locating, we can calculate the slope, sorry, by locating the data points, plugging them into this equation, or if you're given the actual data points in this form, you can still plug them into the same equation. We talked about the positive and negative slopes. What if you had a graph that looked like this? Well, let's see here. In green, what would be the slope of that graph. Imagine that it's a straight line all the way across. So the slope here would actually be 0, right? Even though it's horizontal, okay, you will have a change in the, if you select any 2 points on the x-axis, right, you will have a change in that value. But if you look at the change in the y-axis, there's no change in the y-axis, right? So the rise there is actually 0, and that's divided by the run, and the run is going, we just established, is going to have a positive value. 0 divided by anything gives you 0. Hence, the slope there is 0. If, on the other hand, I had a graph or a line that looks like this, so it's a vertical line, imagine that's a straight line, well, then we have the opposite happening, right? So my slope equals the rise over the run, okay? Well, now if I select any 2 points along this this graph, well, obviously I'm going to have a rise here. But what's my run? Well, I don't have a difference in the x-axis because it's all at whatever this value is, right? Whatever that x. So that difference in the run is actually 0. So you divide a number by 0, you end up with an undefined value. So the slope there is actually undefined. So we have generally 4 types of slopes that we'll see: positive slope, negative slope, slope is 0. If it's a horizontal line or if it's a vertical line, it's undefined.